people if they are able to join. We will, as usual, record the session so that we can make it available to those that weren't able to join us and be with us today, because obviously we want to share the message far and wide. And this is something of a niche topic that we're talking about this afternoon. So this afternoon's topic is being presented by Chris Mollison, CEO of Scheduling Solutions South Africa. I will let Chris do a bit of introduction about himself, but we are looking at advanced production scheduling, where it is and where it fits into the supply chain. So advanced production scheduling tools can deliver significant benefits to a company when used correctly. This webinar covers how advanced planning solutions work, why it generates the benefits reported, and how it fits in with other functional areas in the supply chain. These discussions will cover the merits of using an APS relative to techniques such as MPS, MRP, DDMRP, theory of constraints, and lean. So, Chris, I hand it over to you if you'd like to introduce yourself and continue with the session.
Thank you very much, Tanya. And again, thank you very much for giving me the opportunity to present in your webinar series. Please let me know if I talk too quietly. I hate to either be shouting or whispering, so please let me know. Okay, so I'm hoping that this afternoon's presentation will be informative and help people better understand what advanced production scheduling is. With that in mind, let's just, as you can see from my gray hair, I have been around a while. I've been in this sort of industry, logistics, supply chain, for a great many years. I think I got a CPIM in about 1981, so a little while ago. All right, so with that in mind, let's have a look at the subject matter. We can talk about advanced production scheduling, what it is and where it fits within the supply chain. Tanya did mention that I would compare it to other techniques, and we'll do that as we go through the process as opposed to specific comparative analysis. Okay, so advanced production scheduling, by the sound of the name, focuses mainly on the production environment as opposed to either in sales or distribution, but there are models that in actual fact have been developed for handling distribution type activities, warehouse, unpacking and repacking as an example, and also purchasing in better supply coordination across the process. So, but the main focus would be in production. All right, the way I'm going to do the presentation is I'm going to look at the advanced manufacturing and planning and control system structure, which really is standard theory, and if you opened a book, you'd get something similar to the one I've got on the chart, of which you won't see production scheduling because it's not often recognized the role that it plays. And we'll see how that's changing by the end of the presentation. All right, so we're going to talk about the functionality. What sort of stuff do we want in it? What must it consider? What tools are available? What does it do? And how does it do all that? We'll cover that. Why we use it? What are the pictures we get out of it? And what does it deliver for us? So we'll touch on that. And then, of course, if you are using it, why would you want to use it? What are the benefits of using it? And then the evolution, which I think is a much more interesting subject because it's changing that standard manufacturing, it's changing the standard manufacturing planning and control systems landscape. And we'll look at that right at the end. And then I'll summarize, and then hopefully there'll be one or two questions. All right, so let's look at that standard manufacturing control system functionality, and you'll see that down the right hand here, you've got an ERP system, and these top items are sort of half in, half out, and all the rest are in the system, and there's no detailed production scheduling in this. The closest they get is probably to a different name called detailed capacity planning. And another example of the same planning flow would be forecast to production planning to master production schedule to MRP to shop floor scheduling. And then if you've got a custom order in, the custom order acceptance process would talk to the master production scheduling, master production schedule, looking at available to promise as an example of how you would decide whether or not you could meet that order. And the problem that you have in both of these models is that there are many companies where there is no master production schedule. So a make to order company, for example, doesn't know what to schedule until they get an order. Customers that have stock in silos or very short lead times often don't run MRP simply because it's not a requirement. So MRP is also not commonly used, but scheduling might be used in both of those environments. All right, so let's look at another definition of APS first, because sometimes when we talk about the concept of APS, people in actual fact have an understanding what it means. And the problem is APS in actual fact has more than one meaning. So I'm going to touch on the advanced planning system just to go through the functionality that you find in that, which is different from advanced production scheduling. So let's do that. So we have an ERP system. The ERP system normally has some sort of input called a forecast, which starts talking about when and how many we want from a planning perspective. Then we have an MPS, and it's an optional issue. Not every company needs an MPS or has one. Then we have inventory optimization, another best of breed product that was developed. And obviously inventory optimization is trying to determine the amount of stock you should have against a category of stock, an A item versus a B item, etc., and how much money you need to invest to get the service level you want or the sales values you want. And then you have demand planning, because often in forecasting and in finished goods, you might have a seasonality factor involved. And so you might not be able to make that product in the season in which you're going to sell it, and you might need to make it in an earlier season. And so you get demand planning that looks at resource planning. Do I need more machines? Capacity planning. Do I need more shifts? And how do I order material for long lead time items? And that might be done with a planning book. And the flow is obviously top to bottom. We have a forecast, goes into inventory optimization, through to demand planning, through to an MPS, and so on. And we bracket all of that, or we lump all of those together in a process called sales and operations planning. And then we added additional functionality to this, which are things like transport and warehouse and DRP and all the rest. And we call those the advanced planning system. So that's an APS. In the use of advanced planning system is a set of functionality that determines how the future production should work at a fairly high level. And hopefully that's understood. All right, so let's go back to what sort of time horizon the advanced planning system runs. So it's normally across months and years, months, quarters, years. But there are some industries where you might be planning right into days. So if you think of salads and fresh and sandwiches, you have a very short shelf life, and so as a result, you need to be very short shelf life, and you need to be planning today for what the customer may order tomorrow, and you can't build a lot of stock because there's a shelf life involved. And so the end of the day, what is going to happen is you're going to plan at lunchtime to see what you can top up this afternoon that you hope will be a part of a custom order tomorrow. So planning could be very short lead times. Let's go back to our problems with a standard model. We said that some companies don't have MRP process or don't have MPS process, but where you do have one, the problem is really that lead times are not, MRP uses a fixed lead time to determine when to start the production of the lower level item, and those lead times are in actual fact flexible. So the problem with these standard control system functions is they don't recognize that lead time is actually a variable. All right, so we take this example. I'm standing here on day one, and I have three orders in the system at the moment. One I'm going to do today, which I'm going to ship tomorrow. One I'm going to do tomorrow, I'm going to ship on day 3. And then because I don't have access to the machine on day 3, I'm going to manufacture on day 4 and ship on day 5. And today I get in another order, and the salesperson says to me, what is my lead time? And well, my lead time in actual fact is 8 days, because I can only make it on the 5th day. There's a weekend in the way, and so I can only ship it on on the 8th day. And then I get another order comes in, they ask me what is the lead time, and it's 9 days. So we've seen, and then I suddenly get 2 orders and it's 11 days. So we see that the lead time is really a function of the availability of capacity in most cases. It's determined by capacity in most cases. But occasionally, even if I have capacity, I can't, I can flex capacity before I worry about other things. I can work overtime, work shifts, put in subcontract. And so I can actually change that by working weekend. In this example, I could suddenly bring orders in or move the maintenance to another day, and that would change the lead time for the next order. Okay. But sometimes, even if I have capacity, I can't manufacture the item that I want, simply because I'm dependent on materials or tooling or setups or skills or some other issue that is involved. So the problem that we see then is that MRP doesn't take this variability into account. And so that has created an example, here I'm going to give you an example of that problem where lead time in actual fact is dependent on capacity. So I have 3 orders, a blue order, a yellow order, and a red order. Each order goes through 4 operations, and you can see it's machine 1 and 2 for operation 10, machine 2 and 4 for operation 20, and so on, okay? And I've got some business rules, and so what I want to do is take the first order, which is the highest, the blue order is priority 1, and I want to schedule that. So I allocate the work to resources, and I use up some capacity in the plant. Then I take the yellow order and I schedule it. And what we see happening is that even if I follow the business rules, that the lead time for the yellow order in actual fact is shorter than the lead time for the blue order, because it used different resources to meet the requirements of that order. So again, I'm faced with a situation that even if products are similar, the lead time is dependent on capacity. And if I look at the red order in the top on machine 1, I couldn't get it onto production either because it is either occupied by a blue order or a yellow order, and therefore the delivery date was impacted by the use of capacity. So that's a lead time example in across machines as opposed to in one simple machine. And this example ignores material and capacity. Sorry, it's only taking capacity, it's ignoring material and tools. And then scheduling horizons, if I look at them, could go from minutes or days. So that salad example, I might only schedule for the next 2 or 3 shifts. There's no point in scheduling further. I might plan for a week's worth of work or 2 weeks worth of work, but not schedule. So I might have a very short schedule. And then in companies that have industrial equipment, where they're making to order, engineer to order, the lead time could be 6, 8, 9, 10, 12 months. So depending on their load at that point in time. All right, so let's talk about advanced production scheduling. So we saw that we had a standard module, and the standard module didn't really handle lead times very well. So we saw the development of advanced production scheduling solutions. And so why were they developed? Well, clearly lead time, the ability to take constraints and consider constraints in volume and all the rest were needed to be considered. And then finally we went along and we had some solution on what it looked like. So what does an advanced production scheduling solution try and solve? What does it consider in solving that? And what does it look like at the end? All right, so we said it has to project lead times. That's one of the requirements of the solution. It has to be able to handle large volumes. We have companies where the number of operations to be scheduled on the board could be as many as 10,000. So, and so it has to be able to put those into account while recognizing capacity and skills and bills of material and all the rest of it that goes into scheduling, okay? The customer constantly changes their mind. In clothing, in fashion retail, for example, we keep very low stocks because we need to react very quickly to fashion changes. So if something's fashionable, we want to get stock in really quickly, and that's changing. That requirement is changing the whole clothing industry from holding lots of stock to being much more agile in the form of response. We also get business opportunities. Arrive, the person says that my supplier can't do this, I need it urgently, can you do it? And so the business opportunities that arrive, or penalties get placed on us for late delivery, and we need to cater for them. We have lots of scheduling complexity, which overwhelms the ability of a scheduler or a human or even simple systems to manage all the complexity and optimize setup reduction and so on. And then finally, when we've got the schedule created, we want to tell people what to do, and we want to tell them in the order in which they must do it. So we not only want to coordinate the department, but we want to synchronize the activities with all the other activities so that we get the best throughput out of the factory. All right, so what do we need to consider? Well, we need to consider shifts. Clearly, that's one of the issues we need to worry about. We need to worry about availability of tools. So tools might be something I only need in a setup, or something I need for the whole job, or something I need that will stay with the job for 3 or 4 operations. So I need to consider tools. I need to consider run rates. Am I making a batch of things in a chemical composition where I make 50 or 500, it takes the same time, or am I looking at a run rate where I get a certain number per hour? In many factories, there are alternate routings and alternate run rates, and I need to consider those. In most implementations, not all the information needed for scheduling is available in the ERP system, so setup matrices, run speeds, tool usage, and you have to go and find that information somewhere else. Some industries have stock allocation rules. You can't make this product out of 2 raw material batches. You only can ever use 1 raw material batch. Scheduling speed is critical. If I want to be able to schedule in seconds, then I can't run whatever that scheduling engine is. It must do that very quickly, otherwise I don't get the benefit of it. And do I want to consider heuristics or optimization when I run this? All right, so let's look at the solution. So we need a whole lot of data. It's calendars and inventory and purchase orders and routings and runtimes and bills of material and progress in the factory and attributes. Is it yellow? Is it green? Is it wide? Is it thin? Is it thick? Is it, whatever I need for scheduling purposes or for decision-making purposes, I need to bring in with the rest of the data. I take all that data into, call it a data integration process. That could be an API. It could be a CSV files. It could be direct reads. It could be XML files. Whatever the issues are, I put all that through a scheduling engine to take all those considerations into account and all the rules and the business issues that I need to worry about. And then I provide that output, and the output is often, most frequently, a Gantt form, but I'm using colors to transfer information to make people understand it easier. I'm using text in reports, I'm using graphs, I'm using plots, whatever I need to do to make the user assimilate the result of the scheduling engine to help them with decision making is what I need to do. Okay. The scheduling engine is the differentiator between solutions. We've seen over time that scheduling engines or scheduling solutions have come onto the market, and they talk a nice story, but the scheduling engine is inadequate. And so the end result, which is that it can't handle the company's scheduling requirements because the engine is not capable. Okay, so here's an output of a series of outputs from a schedule, and you can see we've got a Gantt chart and the colors on the Gantt chart, and the colors mean something to that scheduler. And then we have plots that have different colors that again mean something to the scheduler. We have bill of materials structures and supply chain linkages, and we have loads on the plant based on the scheduled work. So that would be an output that the scheduling engines or scheduling solutions have largely the same sort of outputs, but they could differ slightly between solutions. But that's the sort of stuff you're going to find in them. All right, the scheduling engine, the standard functionality, What's marked in green here are examples of scheduling functionality. I've shown you the forward schedule a couple of seconds ago. So you might want to do forward or backward or wave scheduling. Wave scheduling is schedule all the production orders that for which I've got custom orders, then schedule all the A items, and then schedule all the B items, or schedule all the C items, and so on. So those are, that's wave scheduling. Do it when I schedule, do it by priority or do it by attribute, do by directional scheduling, schedule forward to the bottleneck and then schedule backwards from the bottleneck so that I don't start work too soon. And that's very equivalent to a minimum working process, which I'll show you in a minute. Preferred sequence is I want to schedule, and I want to schedule in some sequence that minimizes setup, and I could be taking into account allergens or colors or some other criteria that impact setup. And if I run them in some order, I in actual fact get I reduce the setup and I get more work out of the plant. I could run campaigns. A campaign is take all the work in the next 2 weeks and schedule that as optimally as you can, and don't go more than 2 weeks, and then take the 2 weeks after that and schedule that efficiently. But don't schedule all 4 weeks efficiently, because then I don't meet the customer demand. I do ovens and fridges, another type of example where I make different products, but they go into an oven, and only when the oven is full does the schedule proceed. So keep that take that into account when the oven opens and closes, because that fixes the timing of every subsequent operation. And I might have special customer rules that I need to run that are unique to that environment, that there's no way that you could have created a standard function for that, because it's something entirely specific to that customer, and it may or may not include optimization. When you've got the scheduling engine, does it cater for drag and drop? Does it cater for operation splitting? Quite often in production, we run to a point and then we break into that production to do something else urgent. But now I've got one part that hasn't been done and one part that has been done. How do I handle operation splitting? Okay. Another one that we see quite often is I might have in refurbishment or in clothes manufacturing or in low volume, let's say furniture manufacturer, I might have a production process that looks like this, call it a project chart. And in standard ERP, I would have a production order for A and B, another production order for C and D, and then a production order for G. And then I would receive all these items into stock, and then I'd issue them to E, and I'd have another production order for E and F to the end. But there are mechanisms where you can define this all as a project and have one production order that represents that whole process, and it will tell each of the departments what they need to work on in the right sequence. So it cuts back tremendously on paperwork inside the factory. So the scheduling engine may or may not be able to take that into account. All right, so let's look at some of these rules. One I didn't mention was load leveling. So we saw here that this operation could run on machine 1 or machine 2. This one could run on machine 2 or 4. This one only ran on 3, and then this one also only ran on 2 and 4. So load leveling is when the scheduling engine runs, it must consider where the work can go. And so what it does is it considers which one will end first in this heuristic. And so it'll pick that it'll go on machine 10, and it'll do the same for machine 20, for operation 20. Pick that one, 30 can only go there. Look at 40, pick this one because that'll finish earlier. So I'm running 2 heuristics here. The first heuristic is in actual fact that I'm scheduling by order. There are other ways of doing this. And the second one is I'm load leveling by using earliest finish date. Okay. And then I take the next one. So clearly here, even though they run the same time length, I will finish earliest on machine 2. So I'll run that there. And then the same goes again. So the end result is that the job finishes as early as it is possible. Every time I place an order on the board with this heuristic, I am consuming capacity that the next job may have wanted. Okay, so but the end result is even if I do this, I will end up with a feasible plan that meets the business requirement of scheduling in the order in which I want product to go through. All right, so that's a heuristic called load leveling. Then we have a minimum working process forward. So I put the first order in. I can only start it at this point because it will end there. But if I look at the next order, then you can see there's a gap, a time gap. I started, then the job waited before it went on, then it waited before it went on, and waited. So if I use this time frame of when 40 starts, and in actual fact I backward schedule, then I would reduce the time that work was in the factory. So that's a thing called minimum. It's a standard, again, a heuristic of how you'd minimize working process without affecting the system. Here's a heuristic looking at reducing setup. So I've got 4 days, day 1, 2, 3, 4. I've got orders white, yellow, and pink. This one is due on day 1. These are due on day 2. These are due on day 3. This is due on day 4. If I put the 2 white orders next to each other, I would avoid having to do a setup. If I put the 2 yellow jobs next to each other, I would avoid doing the setup in the same for purple. So what happens if I use a heuristic called look ahead for 2 days? So I'll schedule the white, then I'll go 1, 2 days. There is another white. I'll bring that closer to that. Then I'll have a yellow. The yellow would now start over here. I'd go 1, 2. There is a yellow. I'd bring the yellows together. So that's this heuristic. And so if I do that, what happens is I get fewer setups, which means that the plant is more efficient. I'm taking less time to do the work. And in this particular case, I'm only going to be late on 1 order, whereas in the previous setup, I was late on 2. So this is such a good thing. I'm going to try it with 3 days. I do that. And so now I'm 2 orders late. And in actual fact, I'm more efficient at the expense of orders. So this is a heuristic that the scheduling engine might use. And it's really also an indicator that some of the solutions that the scheduling engine that you may use in the scheduling engine don't give you an optimal answer. There isn't an optimal answer in this case. If the plant is very busy, I might want to annoy these customers to get more work through. If the plant is not busy, I might be happy to take an extra setup if it means that I'm only going to have to deal with 1 customer. So there's often no right answer, but I'm always going to get the same answer with heuristic. Here's one where I'm doing an oven load. So I'm doing some sort of preparation. Then I need to go in the oven, but the oven is not full, so I can't close the door. I run another job. The oven is not full, so I can't close the door. Now I run the 3rd job, and the oven is full. So these oven jobs are all going to start and end at the same time. So that would be, I would need to reschedule them to the same start and end. I could now delay the schedule of this light blue P1 to start later and end later, so because that's the first time we're going to the oven. Then if I run another job, exactly the same process occurs, and this logic, this heuristic that I'm dealing with could be ovens or fridges or containers where I'm shipping something to somewhere and I can't ship it until the container is full. I might fill the container and then backward schedule from that. Okay, so that's an example of an oven rule in a scheduling engine. All right, so let's talk about the benefits of using an APS. So first of all, we see the functions of the solution. What do we get out of it? Well, we see that it's consistent. Every time I run it, I get exactly the same answer by and large. If I run a simulation schedule, what might happen is the random number I choose on this run may be different from the random number of the previous run. It might give me a different answer. I should get a feasible plan. I won't consume materials that I can't actually ship because in actual fact, I don't have all the components available. So I would have a feasible plan that allows me to work and hopefully prevents mistakes in the scheduling process. I'm going to have much faster, I'm going to have dramatically increase scheduling speed. I'm going to be able to do what ifs, I'm going to visualize, so I'm going to improve my decision making in this process. Because I can pass the schedules down to the plant, they do it in the right order, I'm effectively getting the plant to work in the right order to get some job done the most efficient way. So let's look at one company that tells us they increased their business by 500% over 10 years simply because they scheduled. They don't have an ERP system, or they have a very small ERP system. And they were 50 employees. They were obviously much smaller when they started. And their success, their job shop, their success lies, in their opinion, entirely within the fact that they schedule their work through the factory more cleverly. This one, another job shop, they grew 300%. They tried various ERP combined scheduling solutions. None of them worked. They eventually found a scheduling solution that they liked, and they rewrote themselves. They rewrote the ERP solution. Small shop. Now when they need more business, they just drop the price. They know they'll beat anybody out there for flexibility and for delivery performance. So that's them. Okay. Results out of when I'm doing this, because I can coordinate better. Firstly, I get incredible improvements generally in customer service. I start getting much better delivery date promises, and I'm able to adhere to the schedule or the promise that I made. I'm able to manage changes. The customer comes to me and says, I want you to, I know I gave you these priorities last week, but I need to change them because my customers have changed their mind, and you can manage that change without necessarily breaking promises to other customers. Then you need progress feedback. The customers often say, where are you? How far are you? And in most factories, they walk around the plant to do that. If you've got a scheduling solution, they in actual fact can tell straight away. And you could ship that information to them by email on a regular basis. Case studies are 40+% productivity gains. We have a number of those. They're not unique to us. Different tools will give you the same sort of benefit sets. So we have one where they have 80 plant operators, make complex industrial equipment. They refurbish, they handle emergency repairs, they make spare parts. When their system started working, they got a 45% increase in productivity with factory operators involved. That's a very big bottom line delivery for them. We have another customer that have a very complex molding environment. They make plastic bottles. The plastic bottles have different necks. The necks have different sizes. And so when you put the mold or the tool onto the machine, it in actual fact is a composite of body and neck and color and all sorts of stuff. So in their case, the tool, they only have a limited number of necks, limited number of bodies, and depending if the mold ran, cavities could run on more than one machine or could only be limited to a machine. So the end result was that it took them all day to create a schedule for only 2 or 3 days. When that finally worked, when we solved the problem for them, they could schedule the full order horizon book, and it only took minutes to do that. So they went from on their customers, they were marked as a red supplier because they were so poor. They got dramatic customer service increases as a result of being able to schedule consistently using all the variables, taking all the variables into account to give them an answer. Some companies chase different end results. Some reduce raw material, others are looking for productivity, others are looking for customer service, or some combination of those. And normally we would see some reduction in one of those areas from stock point anyway. And one of the big things, because we're automating the scheduling process, is we'll get a reduction in the scheduling effort by 80%. We'll move these people to look at routings and bills so the plant doesn't lose them, but you no longer have expediters and you no longer have expedite meetings because the schedule is managing that. ROI can be very short. The best I've ever heard was an ROI for a multi-million euro project. So think very big numbers, coordinating across different factories. Their ROI was 10 days, but we normally talk weeks or months and no more than that. So because of the benefits we get at the 45 and 47% as being standard. All right, so this company here, by grouping the allergens, decreased from 3 shifts to 2 shifts and achieved an increased output from the factory. So just by better scheduling the sequence mix going through the plant. This one here had a bottleneck machine that really governed. They had multiple plants, but there was one that was governed the whole output process. They thought they were managing that very well, but with consistent and better decision making in the sequencing side, they increased productivity by 15%, about that. And because the system was now doing the work, the 4 people involved in managing all the scheduling activities went down to half a person. Those other 4 people were redeployed into other jobs, and they stopped morning meetings because there wasn't a point in having them. Here's one where they have an automated schedule. We'll talk about automation of order entry in a minute. These people have an automated schedule. The order comes into the factory, it goes into the scheduling solution. The scheduling solution looks where to put it. It can go immediately onto the plant, they can ship it. So in their view, an order comes in 2, they're actually running 2 schedule, and it's 4, 5, 6, and 7, but I made it 1, I brought the time forward. So the order comes in at 2, it's gone into the schedule by 2:30, it's on the factory by 3, it's produced by 4, shipped by 5. But, and this plant competes on flexibility. So they've automated as much of that process as possible, and in automation, they also achieved setup reduction. So, and that's scheduling. You couldn't do that with manual interference. Okay. When you use an MPS, you're under pressure. Sorry, this block should have been hidden. You're under pressure to meet delivery date promises, to provide feedback, to handle priority changes, and it's more than you're able to do manually at the moment. You need to increase profitability by reducing stocks or increasing productivity. Any one of those, any combination of these would make you a candidate for an advanced production scheduling solution. You're going to improve decision making. You may want to improve decision making because you have all these different dynamics in your system. You're changing priorities, and you've got to take into account material and supply and batches and load and capacity and all the rest. So you need to make better decision making. And clearly the advanced production scheduling allows you to do that, to make a feasible plan. We have some companies where that molding example I spoke about, that scheduled all day to get a 1 or 2 day schedule that went out to their full order book, which was about 3 or 4 weeks. We have others where they spent from Monday to Wednesday doing a 3-week schedule, and that's all they could do by Wednesday. And they went to a schedule activity that was a Monday morning, and they ended up scheduling 8 or 9 factories in a network across 6 months. So quite a big change from their point of view, and a much better understanding of the issues they faced. You need to you have a lot of variables to consider. That go back to that molding example. It's the mold and the neck and the shape and the color and all sorts of stuff. You have a lot of tasks to consider, 4,000, 10,000 tasks. It's beyond the ability of a person to schedule that reasonably quickly and unschedule it and reschedule it very quickly. So you need and you have a very complex scheduling process where you need to recognize secondary constraints. These are those skills and tools and the availability of those in creating your schedule. So if you have these conditions, you would look to use an APS. When you use one, your focus switches from shouting and running around and expediting to one of making sure that data is correct. So you suddenly need to ensure that your data is correct and as complete as possible so that the whole process works correctly. You need shop floor feedback. If you don't get it, your schedule is inaccurate. So you need to focus on getting data feedback. You need to have methods and procedures so that if something goes wrong, how do you deal with it? How does the plant work? What do you do? What's the correct steps? And you need to make sure that they rigorously adhere to. And then, of course, you need to education skills so that those people, whether it's the shop floor feedback or the person with the routing or the bill of material or the scheduler, all understand what it is they're trying to do and what the capabilities of the system are to help them. All right, when not to use the system, you've got no pressure on operations, the company is sufficiently profitable, you're very productive, you can't improve scheduling, it takes 3 minutes, you've got low volume, low manufacturing complexity, and a very flat and simple bill of material. And your management style is hero versus Sun Tzu. And Sun Tzu is the guy who wrote The Art of Warfare, and his premise was the earlier you can identify a problem and resolve it, the smaller the implications are. And that you do by having the data and the system to manage it. But in some companies, the management like to be heroes. They like to solve things. They like to expedite. They like to have the meetings. They like to feel efficient. If you've got that sort of environment, then scheduling is in conflict with that, and so it doesn't work well. And some companies are not worried that the data is wrong, so you can't put in a scheduling system unless you change the focus on the data. And education is a problem. They don't see the need to gain a 45% productivity increase. You need a different set of skills to run the system, and they don't see that there's a need to do that. All right, let's talk APS evolution. This is probably one of the more interesting subjects. We spoke about the APS, the current manufacturing planning control hierarchy or system structure, having shop floor scheduling way down the back there. And we said that they run a master schedule and an ERP and order acceptance. So let's look at how this has changed. So as we added more considerations into the scheduling, we created best of breed advanced production scheduling solutions. Okay, and there were a number of these that came to life, all trying to manage these various factors in a way that was completely outside mass production schedule and an MRP one. And then what they found is that you needed the shop floor feedback. It was no good making a schedule if nobody followed it or it was wrong and you didn't get the feedback. And so the APS and the MPS became more closely connected, and so much so that today we say that the APS and the MES are Siamese twins, and MES is a manufacturing execution system. And they're Siamese twins. If you don't have feedback mechanism, then your schedule goes wrong and then you don't get the benefit. So this link became much more important. And today what we see happening is you see product lifecycle management tools starting to come out, and product lifecycle management tools now define what the schedule should be looking at from an execution point of view, which could be the sequence in which you do the task, the quality steps you must go through, the various bits and pieces which you don't need in the scheduling. So a lighter version goes into the schedule, but in here would now be all that missing information that isn't found in the ERP system: alternate routes, setup matrices, different run times, materials involved, attributes, and so on. So that would go into the APS. And now we're seeing the PLM pass a summarized routing to the ERP system. So the APS no longer fetches the routing and the BOM from the ERP, but in actual fact may put it back there, but fetches the main detail from the PLM. Okay, so that's a change that's busy happening at the moment, but it's not the only one. What we're also starting to see is order promising going through to the APS. So now the advanced production scheduling is being asked, can I do this order? And the order entry process is now online. So they ask, and then the system says, yes, I can do it for you in 3 days. And if they accept it, only then does it enter the ERP system through the process. And now, because I'm running to be able to answer the order entry question inside the schedule to get a proper answer, in fact, I'm running MRP at the same time. So MRP has come out of the ERP system and is coming into the APS system. So these are the evolutionary changes. So if we go back to that earlier picture which showed the APS or the scheduling right at the bottom of that set of functionality, in actual fact, the APS is becoming almost a dominant function within manufacturing environments that want to be much more agile, more flexible, want to dominate customer service and so on, okay? And then of course, this is all going web-based now. And one other one that I haven't built into here is that solutions now run from planning all the way through to scheduling. And so these are now called advanced planning and scheduling solutions. So still in APS, advanced planning, we're starting to see the development of these solutions. So ERP is being relegated to a smaller and smaller role within the factory because of the power of alternate systems, PLM to define the logic, hold the drawings, keep all the details, manufacturing to manage quality and production activities in a far more controlled way, advanced production scheduling to actually look at where the factory can do the job, and using MRP processing in that. All right, so that's the order entry. All right, in summary then, the APS, or Advanced Production Scheduling module, is a supply chain planning tool. It's used when, among others, there are complex schedules, there's frequent and rapid rescheduling required prior to every shift, or maybe even in a shift. At the trigger point of everything happening, we need to reschedule. Companies under pressure, you might use an APS if you're trying to improve customer service or productivity, and obviously from that profitability. We can see from a great many case studies, not just the ones we're familiar with, great many case studies that you will improve customer service productivity and probably reduce stock. But a key issue is it requires alternate management focus around data, schedule adherence, and use of the system. Right, that's me on my 50 bits. Are there any questions? And anybody wants to ask about advanced production scheduling?
Hi, Chris. I have a question.
Sure.
So, in your final diagram where you had the ERP, the APS, all as external systems, so the ERP is the smaller one.
This one.
Yeah.
Yeah.
Where do your external warehouses, etc., sit with their inventory levels to be taken into account when you're starting to plan what you need to make?
The ERP system still maintains records around procurement, around stock warehousing and stock values, and you'd read those in from the ERP system into the APS. You're not trying to put that functionality into the APS. So that functionality stays there. But one other thing, warehouse systems now often also carving a bit out of the ERP system because they have that functionality. But to summarize that, the APS reads that information from the ERP. And then in the scheduling, last one, in the scheduling, it has the ability to go along and say, I first consume from the stock on the floor, then from the warehouse on site, then the call-in warehouse, then the orders that are in shipment, then the orders that are finished but not yet shipped, and so on, all the way up the supply chain. So you can make the APS recognize those situations.
Okay, that makes sense.
Other questions? The cold weather makes everybody very quiet.
Arthi, if I may ask,
Yes.
what industry do you work with that you might have that?
So I implement an ERP, but we're currently busy on a big project where certain parts of the ERP are actually being taken out of the ERP. So for example, order entry, the way you've got it, a pull system, for example, that will be external. There's a warehouse management system, and they're all communicating with each other and the ERP. So I was very interested to see your drawing because it's along the same lines where a lot has been taken either out of the ERP or there's a backwards and forwards communication between all the systems.
Yes, what you see happening is that depending on the business environment is because these tools are so efficient. So an APS, for example, can schedule so much more quickly. What you're finding is that you start looking at the best functionality in the different sections to get the business result you want. So ERP is no longer the center, but it is just one of the modules inside the system landscape for that company, which is what it sounds like in your environment.
Correct. So we deal mainly in FMCG.
Okay.
So yeah, it's a very fast-paced production environment. So
Yes.
it's interesting to see this.
Yes.
Do you use
Sorry?
Do you use a specific software for your production scheduling?
We have been using a Siemens product. It wasn't Siemens before. Siemens bought it. But we've worked with other tools before, and I've tried to make this tool independent. In other words, solution independent, because they're all sort of moving in the same way. Some work, some don't. That scheduling engine turns out to be the key to the way you solve the problem. I don't know if that makes sense to you. If you don't have the functionality in the scheduling engine, you end up compromising the way you run the system from what you could have got to what you do.
Correct.
Yeah. In FMCG, there's a very interesting quote from somebody from Unilever in Europe that went along and said, agility beats forecasting 10-1. In other words, the ability to flex backwards and forwards
Yes.
with mix and volume beats the hell out of forecasting, because the customer never buys what you thought he would be anyway. So how quickly you can flex so that you avoid product with shelf life problems, product with wrong mix, allocating raw materials to products you didn't sell, whatever. There's hundreds of them. So the scheduling gives you the ability to be much more flexible to stay abreast of the changes that are happening in the sales and marketing environment. I'm sorry, last thing, I'm not suggesting you don't have stock. It makes a lot of sense to hold stock somewhere in those environments. It's just that sometimes it should be a combination of stock and agility.
Yeah, because you do end up with overstocking, which
Yes.
items that might actually become obsolete, and then you're sitting with stock.
Yes. Do you know that
Or you just
the clothing manufacturer Zara is completely, Zara is one of them, they number them. Zara is completely changing the clothing retail industry, because their model is rapid response, low volume, low stock, rapid response. And the old models were high stock holdings, cheap materials. And Zara charges more, but changes quickly and flexes quickly. And they are forcing almost all the fashion retail to go from a stock holding position to a rapid response situation. So as an example of the sort of change you're talking about.
Yeah. Okay.
And the more products, sorry, one last thing on the FMCG, the more products that the factory produces, the greater the need for flexibility. You know, if you're only making, I don't know, pick Handy Andy, and your line just runs, 3 versions of Handy Andy or 4 versions of tomato sauce or some such, then you don't need a scheduling solution. You don't have enough variability. But
Well,
so
can I ask you a quick question in line with that?
yes,
If a
sure.
customer has multiple manufacturing sites, how would
Yes.
that work with APS?
There are numerous examples of single APS running multiple plants.
Okay.
In other words, so that the orders come in centrally, you group them around on the different plants, and you get the plants to run the volumes that you want, and you start trading off distribution distance, if that makes sense. So,
Yes, yeah.
so Cape Town needed more product. You try and make it out of the Bloemfontein plant, if that makes sense, not out of the Durban plant. But if Joburg overflowed, you could do Durban or Bloemfontein. If I'm just using examples out of my head.
Yeah.
But I mean, so, and you'd run that, you could run that all out of one site. And in actual fact, we used to have a customer that did that.
Okay. Okay, thank you very much.
Pleasure.
No other questions from the floor? Some of our usual suspects are very quiet this afternoon. Cold weather has obviously got to them. So I think that if there are no more immediate questions, you may think of something after the session later on that springs to mind. Chris, you don't mind if we share your email address?
Not at all.
We'll send out a link to the recording to everybody and a set of the slide deck and Chris's details. So if you'd like to get more information or engage with him on further discussions, that information will be available to you. Chris, thank you so much for your time this afternoon and for supporting SAPEX through this webinar. And we look forward to some more in the future. Thank you all for attending and for being with us on this very cold and chilly afternoon. Take care, everybody, and until next time.
Thank you,
Good
Tanya.
afternoon.
Thank you to SAPEX.
Thank you very much.
Thanks, guys.
Thank you.
Thanks.